Hello and welcome back to this course on fundamentals of data science. This time we are going to discuss in detail about machine learning and various algorithms that are related with the machine learning methods, which can be useful for the data science as a whole in data analysis as well as in various parts of data processing. So this is what we have for today. We are going to see introduction to machine learning. We'll consider supervised and unsupervised learning methods along with the reinforcement learning. The main objective of today's class is to get to know what is a machine learning is, and we are going to differentiate various different types of learnings like supervised, semi-supervised, unsupervised. These are three different types of learning methods, and we do have another interesting learning method is called reinforcement learning. Most of the time we are going to use these types of learning methods in some parts or some modules of the data science processing, as well as for various analysis. We use some of these algorithms to help us. Let's check in what is a machine learning is. Basically, a machine learning is a study of computer algorithms that improves automatically through experience. As you can see, it says improves automatically through experience, which means it's kind of a learning process that as humans we also do the same learning process. So we have to consider how this machine learning methods can be actually modeled. When you have a set of data, you are going to either train this data or you have to directly want to feed this data into your system, and you want the system to perform some simple process like classification, for example. So this method which I mentioned about training as well as without training, they are also related to different types of machine learning methods. Basically, machine learning mostly it's used for predictions, making decisions, for classifications, and it has been used in many fields, and many applications of machine learning can also be found in, say, computer vision, for example. And basic machine learning method can also be found in as simple as email filtering, like spam and non-spam. So in data mining also we can see various way of data analysis process are being used using the so-called unsupervised learning. Let's examine more about these different types of machine learning methods soon, but let's consider what and how this machine learning itself is influencing various aspects of, say, artificial intelligence as well as data science. This machine learning can be as does as simple task as just identifying whether an email is spam or non-spam, or it can also identify a simple relationship just with whatever input it has, or with the similarity of various data. It can solve a very simple problem even without training or even without learning. So that's a very simple task. On the other hand, it can also does some complex task just like humans. It can actually perform, once you train the system to perform certain aspects of learning, it can actually do that. So this whole process, for example, the reinforcement learning is one of the examples of more advanced tasks. So that's why this reinforcement learning has been used widely in many applications. For example, in AI, for example, many game-based algorithms are based on reinforcement learning. You might be familiar with the Deep Blue or AlphaGo, for example. They are kind of trained, and it has been learning by means of reinforcement process. Well, today we are going to discuss more on this aspect. Now you got to know what a machine learning is. Yes, machines are trained, or in other words, they gain experience as you feed in the data and try to train the system with the whole process. Later on in this course, you will know what is this actual training is and how we can minimize the error when you perform the actual testing process. So today let's further examine what are the different ways in which we are going to do this machine learning process, as we have seen earlier. But before we dive into that, here's a very brief timeline of machine learning. Yeah, even before like 70, 80 years before, we already had certain statistical methods. They are very useful for machine learning process. And today we also deal with the so-called deep learning, which in fact has a lot to do with machine learning in general. Though machine learning and AI at times they do overlap, but we can see the machine learning itself has been there for a long time. Though things have been developed in 1990s, where the machine learning shifts from knowledge-driven approach to a data-driven approach. And as we know that the big data and big data analytics came into the picture, where the machine learning is also used very widely. And since then, there are a lot of developments happened in machine learning community, and a lot of researchers are still contributing a lot to the core kernel of the machine learning. Though this basic algorithms in machine learning are widely used in almost all the fields. If you consider, say, the field of bioinformatics, or in the field of, say, library science or education, almost every area we can see how this has been influencing these days. Let's see the different types of machine learning. As machine learning can be categorized into several different types. As a whole, you can see there are 4 basic types. One is called supervised learning, a very basic method in which you are going to identify already known labels. The other one is called unsupervised learning method. Then comes a semi-supervised learning. Well, these 3, supervised, unsupervised, semi-supervised, they can be interrelated, and it can be easily understood. As you can see, the word supervised is there. We will see what it is by definition, and later on we will also examine what this reinforcement learning is. So these are different types of learning methods that are available, and among these types there are several algorithms have been developed based on supervised learning method, based on unsupervised, based on semi-supervised. So these are the basic types. Let's look at one by one here. So here's different machine learning approaches. First one, as we have seen, is called the supervised learning. So here the computer is presented with example inputs and their desired output. For example, you already know what is going to be your output or output labels. So this is given already. So for example, given by a teacher, and the goal is to learn a general rule that applies inputs to output. Just like in a case of supervised learning, say for example you want to classify, say, tablets, I mean the electronic tablets and TV. Your data set has numerous TV images and say electronic tablet images, and your output is supposed to be either TV or tablet. Well, we know that output is already known, what type of classification is made at the output. There's only 2 classifications, one is TV and the other one is tablet. Of course, if you want, you can have more number of classification based on your data set. Suppose your data set has TV, tablet, say mobile phones, and some other electronic devices. So if there is 4 different possible classification can be found in your data sets, and accordingly initially you have to train these data set based on your input, and then at the output you are going to expect 4 different labels. One is TV, the other one is tablet, mobile phone, and other electronic devices. This is supervised. You already know what is the input given to it and what is expected output. We will see an example in a short time. Then comes the unsupervised learning. So here no labels are given to the learning algorithms. Just as I mentioned earlier, input had a data set, and we know the expected labels at the input is TV, tablets, mobile phones, and other electronic devices. And the output also, you know what are the expected labels or classes. You know the name actually for supervised, but for unsupervised you don't know what the label is. Just leaving it on its own to find a structure in the input. So when the algorithm looks at the input, it has to find certain patterns or structures or similarities between those images, and it has to categorize accordingly. So the semi-supervised learning can be a goal in itself, discovering the hidden patterns in the data or mean towards an end feature learning. And in semi-supervised learning, this approach to machine learning that combines a small amount of labeled data with a large amount of unlabeled data during training. So it's a combination of both supervised and unsupervised. So this semi-supervised learning falls between the unsupervised learning with no labeled training data and the supervised learning with only labeled training data. Then comes this reinforcement learning, where a computer program interacts with a dynamic environment in which it must perform a certain goal, such as driving a vehicle or playing a game against an opponent. As it navigates its problem space, the program is to provide feedback that's analogous towards a reward. So whenever it gets a feedback, it's like a reward. It can be a positive reward or negative reward. When you get the feedback, if from the feedback, if you are going towards the goal, then you get good feedback. If it is going away from the goal, you get bad feedback, which means your try, the next try is to be towards the goal, which means that it tries to maximize the reward. That's what it says here. It tries to maximize the reward as it's seen here. So that's one way of looking at this whole structure, maximizing the reward. Let's see in detail what it is. And finally, just a word about the deep learning. Well, as I have mentioned, machine learning and AI is kind of, at times it overlaps a little bit, but AI in general itself has a lot of other mechanisms, methods like probabilistic logic and proportional logics and different knowledge-based systems. Machine learning is just a component where we have several algorithms, like we have seen these different methods. But deep learning, as we know, that it's a broader family of machine learning, which is mostly and originally based on the artificial neural networks with representation learning. So it's a different learning method. And learning can be supervised, semi-supervised, or unsupervised. And this deep learning is a class of machine learning algorithm that uses multiple layers to progressively extract the high-level features from the raw input. And because it has this multiple layer, and we call it as deep because of its hidden layers, they are quite deep into the network. they call as deep learning. So recently, as we know that deep learning has been dominating a lot in different areas, and in the field of machine learning, if we talk about machine learning, suddenly people tend to jump into the topic of deep learning itself, even when you talk about the machine learning. Well, let's come to our basic things that we are talking about, which is different types of machine learning. So here's the first one, which is called the supervised learning. As supervised learning, as I have mentioned earlier, it has a labeled training data. And in supervised learning, you know what is an input and what is the desired output. So we can see that we have a labeled data, and you know what is the input object, and you know what is the desired output value, which means that you know what is going to happen after you receive an output. So that's the basic thought about the supervised learning. A supervised learning algorithm analyzes the training data and produced an inferred function which can be used for mapping new examples. So optimal scenario will allow the algorithm to correctly determine the class label. So optimally, we want to determine accurately what the label is. Like the label we talked about, maybe TV is a label, tablet is a label, mobile phones are a label. It has to clearly identify what is this label. So this requires a learning algorithm to generalize from the training data to unseen situations in a reasonable way. So because you have a set of inputs which may go into any of these labels. So here's a typical example of in fact, supervised learning. So there are several steps involved, as you can see here. You already determine the type of training example before doing anything. You just need to know what training examples do you have. The user should decide what kind of data to be used as a training set. You know the output is going to be certain labels, but what is your input? Your input you should decide, and what are the input training data that you have to decide. For example, if you are talking about handwriting analysis, it might be a single handwritten character, an entire handwritten word, or an entire line of handwriting. So what is that you want to train? Is a single handwritten character, an entire handwritten word, or an entire line of handwritten, or as a whole as a sentence. Then you have to gather the training set. The training set needs to be representative of the real world use of functions. For example, after I train it, I need to identify the handwriting, right? So different people have different styles of writing things. So can the system, say for example, we talk about a different way of writing. Maybe somebody writes this way, somebody writes this way, the same word, Paul. So can this training set can represent the real world use of the function? Our function is the characters or the words in the sentence. Can it represent? Thus a set of input object is gathered and corresponding output are also gathered, either from different forms, maybe from human experts or from measurements or certain data sets you can collect. So you have a labeled data, and you take some of those data are taken with a label, and you do the actual training process. Then after which you are using the certain real world examples to train, and you are expecting they are to provide a result whose output is, say, square and triangle, the labels or square and triangle. So there are in this example there are 3 labels: hexagon, triangle and square, 3 labels, and once you provide the input, it has to accordingly and correctly identify what is the actual labels. So that's the basic thought about this whole supervised learning. And as you can see here, you also have to determine the input feature representation of learned function. So the accuracy of learned function depends strongly on how input object is represented. So if your input object here, as you can see, if input object itself is not clear or it's not well trained, say for example I am just training this system as hexagon, or I am training say this system as square, then the input representation itself is not correct. That's what it means. The input representation should correctly represent the object. So typically the input object is transformed into a feature vector which contains the number of features that are descriptive for the objects. So in some sense this feature representations, some algorithms uses that. A number of features should be too large because the curse of dimensionality, but should certain contain enough information to accurate predict the output, which I mentioned already. So it should contain enough information so that it can accurately predict the output. So these are some of the important points when it comes to the actual process of supervised learning. So determine the structure of learning function corresponding to learning algorithms, and after which you also have to evaluate the system. So there may be many parameters that has to be adjusted to optimize the performance of the system. So you may have to optimize the performance, you have to validate the set, the training set, or the cross validation. After the validation you have to also check for the accuracy of the learned function. These are some of the important tasks for evaluating the performance of your supervised learning. So there are different types of supervised learning algorithms that includes support vector mission, linear regression, logistic regressions, naive Bayes, decision tree, k nearest neighbor, so on. Then comes this unsupervised learning method. As the word says unsupervised, we already know what is an unsupervised learning. Yes, this unsupervised learning is a type of machine learning that looks for previously undetected pattern in a data set with no pre-existing labels, with a minimum number of human supervisions. So in contrast to the supervised learning that usually makes the human labeled input, this unsupervised learning, also known as self-organization, allows for modeling of probability densities over input. Yes, the input you have, but the input data are always without any labels. You don't know what is the input data, but as you can see from human, we know that it is dogs and cats. So you have certain algorithms, unsupervised algorithms. After certain output process, the output classification is happening, but there is no label. It doesn't say it is a cat or dog. There is no labels. In this case there is no labels, right? But it does do the classification without any labels. That's it. That's unsupervised learning. And this method is our main. They have two main methods used in the unsupervised learning, which are principal component and cluster analysis. So these are used for unsupervised learning to cluster or to group them together, to classify them together with certain properties. And there are again lots of unsupervised learning algorithms, like including principal component analysis, singular value decomposition, deep belief nets, k-means, anomaly deductions, generative adversarial networks, self-organizing maps. There are a lot of such unsupervised learning. we do have another learning method which is called the semi-supervised system. As we know that it combines a small set of or small amount of labeled data with a large amount of unlabeled data during this training phase. So this unlabeled data, when used in conjunction with a small amount of labeled data, we can produce the considerable improvement in the learning accuracy. It's just a combination of supervised and unsupervised. In some of the real world examples, sometimes we don't have enough labels, so we can go for this semi-supervised learning. So here is one example you can see here. The example of an unlabeled data is in a semi-supervised learning has been highlighted here. So there's a simple boundary that is given to us, but we do know that in this example we might adopt after seeing only one positive white circle and one negative black circle here in this example, and at the bottom panel shows the decision boundary we might adopt if the addition of two labeled examples are given as a collection of unlabeled data. So you can see the gray circles as the unlabeled data. So this could be viewed as clustering methods, and we classify this black and white accordingly, and then you have some certain unlabeled data which needs an underlying process of training. Finally, we have this reinforcement learning. Yes, this is one of the powerful method of learning. It differs a lot from the other kind of learning in a sense that this reinforcement learning, it operates in an environment where it takes an input and it also expects a feedback from the output, so that the actual learning process and the actual process that is happening can be refined to give a better performance. Maybe this figure can illustrate it quite clearly. So you have this agent, and this agent actually receives an input from the environment. So initially this agent takes an output and this action is given to the environment. Maybe this action is not taking us to the required goal, so the environment also gives a feedback. So from the feedback we come to know that this action is not that one which is desired, so a reward is given. So in this case, when action taken is not useful, then the reward function is giving a negative reward or discouraging the agent to go in the same directions. Then accordingly it moves on from one state to another state. So this environment is typically stated by means of Markov decision process. You are going from one state to another state. So state transition is also happening in the actual reinforcement process. So agent takes an action in an environment which interrupted into a reward and a representation of the state, which is fed back into the actual agent. So just like a child, when he does something good, you may provide a candy or ice cream, which is kind of a reward for the child. So it does the same thing again, it likes to do the same thing again. But on the other hand, it does something naughty, maybe you give him a certain discipline, which is kind of a negative reward. It doesn't encourage the child to do the same thing again. Which is similar thought we are going to go in for this reinforcement learning, and it's one of the powerful tool these days where AI is using for various applications. So that's what we saw today. We saw what is machine learning and different types of machine learning, including supervised, semi-supervised, unsupervised learning method, and finally the reinforcement learning. We have to learn some of these algorithms as a data scientist and as a data science students to implement it later on when you deploy various data science projects. So I highly recommend you to learn those algorithms. Of course, the coming lectures we will learn some of those algorithms, like for example in the next lecture we are going to talk about classification and what are some common classification methods, including some simple classification examples. So that's in for our next lecture. I'm looking forward to see you there. Goodbye.